Good morning. My name is Kevin Rivera, and this is my Physiological Psychology Unit 6 Speech Submission. In the following minutes, I will be covering some of the structures and processes involved in the production of memories, as well as the relation those processes have to cortical, subcortical, or sensory portions of the brain. I will cover how certain environmental factors affect the process of learning in patients with anterograde amnesia, and discuss why these environmental factors do not allow patients to retain memory in addition to their ability to retain a learned skill. Finally, I will discuss how communication skills are controlled on a neurological level. Memory can be broken down into three major types: sensory, short-term, and long-term memory. Sensory memory is said to be fleeting. It remains for a brief period of time after the initial sensation elicited by an environmental stimulus. The concept rings true in situations where you may be deep in thought or hyper-focused on a task. While in this state of concentration, an individual may say something to you, and prior to your mind processing the sounds you've heard, you ask, "What?" Nearly immediately after you've asked your question, you've processed what they've said and have an answer for them. This is known as echoic memory, and because of its sensory implications, it generally does not make it to the next stage of memory. Short-term memory is the second stage of memory and has a considerable uptake on the amount of time that it can be retained as compared to sensory memory. Typically, short-term memory will remain available for seconds or minutes, but can be extended through rehearsal or chunking. Rehearsal can be performed by repeating information in your head or out loud until you need it, and chunking can be utilized by grouping pieces of information together like sections of a phone number. The last stage of memory is argued to be nearly permanent, lasting minutes, hours, or even years. Long-term memory is split into two main groups: declarative and non-declarative memory. Declarative memory, or explicit memory, is generally considered to contain information regarding facts and events, while non-declarative memory consists of a bit more. Non-declarative memory, or implicit memory, is considered to be the type of memory that stores information regarding basic skills, motor movements, verbal qualities, visual images, and emotions. Now, previously I did not realize there was a disconnect between memory and learning, but as discussed between pages 432 and 433 in our Physiological Psychology book, there is information that supports just that. Patients with anterograde amnesia, or difficulty or the inability to learn new information, can learn through stimulus response and can exhibit motor and perceptual learning while still unable to form new memories. As described on page 433, patients with anterograde amnesia can learn to recognize broken drawings. After performing the experiment, the patients were retested months later, and while having no memory of seeing these images before, or even seeing the experimenters before, they still showed the ability to recognize the broken drawings. Now, these experiments are mainly reliant on sensory learning, which can be attributed to the amygdala and is a portion of the subcortical brain tissue. The amygdala and the basal ganglia are both subcortical portions of the brain and can be attributed to the forms of learning described in the experiments previously referenced. While it seems that the learning portions of the brain are mainly subcortical in nature, the opposite can be said for neurological control of communication. Damage to the cortical portions of the brain seem to be linked with understanding, repeating, and forming words for communication. Though this does not seem to be memory-related. Broca's aphasia can be attributed to left frontal lobe damage, though not all damage in this portion of the brain will cause this disorder. A secondary disorder that can stem from this damage is called pure word deafness. The individuals are not deaf in the traditional sense of the word, but are able to perceive and recognize speech and unable to interpret the words they're hearing. Damage to the posterior language area can result in another form of aphasia as well. Patients who suffer with transcortical sensory aphasia retain a connection between the Broca's area of the brain and the Wernicke's area of the brain, and this allows them to repeat words that are spoken to them. However, they are unable to understand the words they are repeating, nor are they able to produce their own intelligible speech. While these disorders do in fact seem daunting, there is hope for patients with these diagnoses. Through word exercises and the use of operant conditioning, as well as the minimization of behaviors such as writing, drawing, mimicry during the exercises, patients with aphasia were shown to improve on their condition. In summary, while these three actions seem fairly distant from one another, it is clear that there are certain links between them. Their interconnecting neural pathways make memory, learning, and communication integral in the function of one another. However, even in cases like dyslexia, apraxia, and aphasia, the brain manages ways to try and make up for the shortcomings of the disorder.